Have you done anything on AI recently?
Not recently. So one of my friends, Chung, he came through. He kind of like got crypto rich. So he runs a crypto collective. So we talked a little about GameFi and what he's investing in. June came on last week, which I need to release episode. Very against the mainstream media. Mainstream media would call it conspiratorial. You know, he was talking about who blew up the Nord Stream pipelines. So he has a very clear view. So he talked a little bit of that.
Who did he think did it? The US?
Yeah, obviously.
Of course.
Yeah.
Yeah. But so nothing on ChatGPT yet since it's launched?
Nothing on... Actually, yeah. So exactly. So we haven't covered AI.
I could do a ChatGPT episode with you.
I'm going to do one with my friend Alan. So Alan is a really super smart guy. He runs a development company here.
We spoke to your LLM friend. What's his name?
Oh, yes. Ku.
Yes.
So I will be going to Bangkok end of this month. I'm hoping to catch up with him as well.
Nice.
So he should have launched the MVP by now.
It's a super exciting time, man. I think these conversations, I think in Southeast Asia, no one's really talking about AI alignment.
That's Ku's biggest concern.
Yeah.
And actually, well, it's in the mainstream media now too, right? The guy's leaving Google.
A little bit, you know, Geoffrey Hinton.
Yeah.
But what I don't like is like a lot of the news seems to cover things like jobs being lost and like the more mundane effects of AI. But the real fear in the Bay is actually super intelligence.
You're talking about AGI, yeah. So like Gary Marcus and this kind of stuff. Yeah. I went on a huge rabbit hole of Gary Marcus. I read like the past like 4 or 5 months of his newsletters.
Yeah, I don't know Gary Marcus.
Oh, you should. Yeah, he's like the biggest proponent of like AI, you know, red flag, danger, slow down. He's
more than Eliza Yudkowsky.
I'm not too sure. I'm not familiar with that name, but I'm sure it's along that camp. But like he's like been known, like he's been around since like AI from like.
That's why most people are leaving. Like there's like now there's corporate greed pushing both all these different models, right?
Yeah.
With very little alignment. The problem is once it's able to write its own code and work independently.
Yeah.
The
good news is if you believe in the Gary Marcus camp, we're like large language models in itself is not enough. Because if you're specifically talking about AI, there's one camp that believes that you don't actually need to know how conscious works to get a like replicate intelligence or at least super intelligence. But Gary Marcus believes you still need a lot of stuff outside of language models to kind of complement that, right? So there's just a lot of things missing. Inherently, it's going to be hardware and data, and you keep scaling that. That will get you far, but still not going to make AGI. So that's his belief. I
think the data speaks against that very strongly. So there's two things, right? One is transformers themselves have it's almost like a baseline neuron, like we discovered a neuron.
Yeah.
And so how scaling laws work right now is that emergent phenomena seems to come out of it at an unprecedented scale. So there's a point where you feed it enough parameters and it learns math. There's a point where you feed it enough parameters and it learns how to tell jokes. There's a point where you feed it enough parameters and it learns to translate. Without being told you need to translate.
So it seems that way, but you can easily break it. It's very good on all the stuff that's existing and what it's been trained on. It cannot.
Zero-shot learning has been impressive with these things. So are you familiar with like zero-shot or few-shot learning?
No.
Okay. If I showed a baby a picture of by baby I mean like maybe let's go with 2-year-old, right? So if I showed a 2-year-old 5 pictures of a cat, different cats, and 5 pictures of a dog, and then I showed an 11th picture, and I said, is this a cat or a dog, right? The baby would be able to identify based on the pictures that I've shown them, right? Now, one-shot learning is if I showed them only 5 of a dog and 1 of a cat, could they identify later? And most human babies are able to do one-shot learning, meaning given one picture, they would be able to identify, right? So anywhere from 1 to whatever, we call it few-shot learning. So the ability to learn with very few training instances. Right? And then the zero-shot learning, which is not being given any context. Could you be able to identify that this was either not one of these categories or that it is its own separate category? So if I showed you it's 5 cats, 5 dogs, and then a bird, would you know that the bird was not one of them? Would you know that the bird is its own category, right? These are very difficult problems, which we thought we needed to build architecture to solve. And they've started to emerge. Like the ability for it to learn from very little data, the ability for it to...
See, I don't know if that's actual intelligence, though. It's just having more data and training in a better way to recognize those patterns, right? So that's where I'm not too sure.
Wow, this scares me, man. Okay, you know what? We should do a podcast about this. I feel people don't really understand how dangerous this shit is yet.
Yeah.
The human brain is fundamentally composed of neurons that turn on and off. They have synaptic junctions and an electrical impulse that passes through them.
Yeah, so we can mimic the hardware, but we still don't know the emergence of consciousness itself.
Consciousness doesn't matter.
It's part of it, isn't it?
No, not at all.
Oh, sorry, maybe put it this way. Sentience?
Does not matter.
This is one camp.
No. It's not just a camp. Like
there's
no one in their scientific like. Listen, the word consciousness has no clear definition. You can't have a debate about.
Yeah. You need to define it.
And the problem is like, what makes you intelligent isn't what makes you conscious.
That means you also believe that you don't need symbolic reasoning for these to become.
No,
sentience.
but it is symbolic reasoning right now.
Ooh.
It is 100%.
You'd have to clarify that because it doesn't.
Wow.
I think it's not the case.
I'm struggling. No.
That's not the case from what I understand.
Not true at all. It is doing symbolic reasoning. It is able to build logical loops.
It cannot reference itself and know.
Yes. Dude, the whole fundamental... Okay. This is really important. Okay. You ready? How much time do we have?
It's up to you, man.
All right. Look. Do you know what makes these models so special? Like what changed in the last 4 years? Like what is a transformer?
Well, you mean in terms of what?
Like, okay, so let's start from the back, right? Neural networks have been around since the 70s.
Yeah.
Like we knew they were doing interesting shit, but it was just another machine learning model.
Yeah.
Then in the early 2010s, we started to throw more like computing power, but the fundamental architecture hadn't really changed yet, right? So we
could process more.
We could process more. I mean, we built a few things, right? So there's something called convolutional neural nets, where basically what a convolution is, it's a mathematical operation that removes the, like, imagine you have an image of a cat, but it could rotate within the image.
Yeah.
In the past, the neural networks needs to always see it the same way. A convolution allows you to almost change the rotation and the transformation so that it's a bit more flexible with how it receives that information, right? So we kind of had some success with visual training through that.
Yeah.
Then with language, we use something called recurrent neural networks, right? What a recurrent neural network is, and this is something that we model after the brain, right? The brain actually has more neurons going backwards than forwards. What do I mean by that? Meaning the input that you receive from your eyes, you have neurons going into your prefrontal cortex. There's actually more neurons going back into the eyes than neurons going into the brain. We don't know what they do exactly, right? But they do serve some kind of purpose with learning and memory, right? What recurrent neural networks did is they kind of built off this idea that so when you have a long chain of text, sometimes it's hard to know how much of it to remember. Basically, if I gave you a whole corpus of language, right? And I'd asked you to find out which words are more likely to follow other words, you'd be able to build out a very interesting table that says after the word the, these words always follow, right? And then you would build a very rudimentary version of a keyboard word guesser, right? The problem is it doesn't have context, and usually after the word the same boring word appears, you'll end up in a repetitive cycle. So what did they do? They did two things. One, they introduced some sort of randomness to how the words get selected. And then the second thing is they found a way to figure out context by looking at words that came before that word, right? So the more I'm able to look back in the past, the more I'm able to identify what this specific word refers to, right? I say Alex sat on the chair. Where did, what was it that Alex sat on? You would know what that it meant based on the previous sentence, right? And so these recurrent neural networks were able to not just input the corpus of the language, but also the words that were coming in. The problem with that was they were very slow, hard to train, and just not very smart. In 2017, Google Brain releases a paper. Very weird paper. When you read this paper, it gives you a neck-tingling feeling, like something's weird, something's off. That paper is called Attention is All You Need. First of all, it's a very cocky name, right? Second of all, the paper is written in a very cocky tone because they've like there is a very clear like we've just discovered gold feeling. They knew they were onto something.
Yeah.
And what they did, so and this is where like if you want to get all juju woo about this, right?
Yeah.
Transformers are built from a little thing called self-attention.
Self-attention.
Yes. It's a little mathematical operation that basically allows the neural network to have an idea of what itself is paying attention to and how much attention it should pay to something.
Mm-hmm.
What would you call a self that is paying attention to something?
Well, I mean, could you explain it in a literal sense, though? How does it work?
So I get
Because
into
this is where
but
I think.
I get into the mathematics of
Yeah.
it. But imagine like at its very simplest like way to explain this, it's a little operation, like a mathematical operation that creates weights. Like actually, let's take a step back. What's a simple way to explain this? So.
Because it sounds like it's just probability, and you train the probability to. I mean, it has to be. It's trained, right? So you assign the probability, and then someone says yes, that's right or not. That's the poor Kenyan worker, getting $2 an hour, right? So essentially, that's not sentience, right? It's trained in a certain way, and then if you prompt it in a certain way, it'll break, right? It's still very brittle in many areas. I think if you have more unique data sets get thrown in and trained well, it gets closer.
No,
but I don't think.
No, Alex, you're completely missing this. I think people need to know this.
Yeah.
It's very close to how the brain works. Very, very, very close. And like this is really like we have a lot of nebulous stuff we call like consciousness, the self, right?
Yeah.
But if you think about it, the brain is a symbolic logic processor.
Yeah, but then current language models don't do symbolic reasoning. That's my understanding of it. So, because if you prompt it in certain ways, it breaks down. There's too much hallucination still. It's trending in the right way, and I think data and the current architecture get you very close to what you're saying.
I'm figuring out what's the best way to explain this, because like I think this stuff makes like the fear only comes when you get into the math. Like it is like right now it sounds like he says, she says, and that there are camps. But I'm very sorry to say that it objectively is able to do logical reasoning. Like this isn't like a debatable topic. Like the process of which transformers actively choose the words that come out is very similar to the processes that synaptic junctions take. And the processes that which it chooses to then create and define and showcase creativity follow the very same steps that logical thinking and creative thinking follow in the human brain. Like there's no like...
We'd have to break this down. You'd have to break it down in a way that's like any like 6-year-old can understand.
Yes, I think I have to do much
better. Let's do another episode where you break that down, because I strongly suspect and you should definitely read the other criticisms to what you're saying, because I don't think I'm expressing them because I don't spend enough time.
You know what? Let's do this. I think I want to do this.
Yeah.
I think it's important that people understand it.
Yeah. Okay.
Yeah.
Because you're from what I understand, at least you're saying it's fact, but there's many people who are saying it's not, right? And then there are groups that kind of coalesce around this where they're kind of against each other. Right? The one thing where I think everyone starts to agree is what you're saying. There was alignment, though, like the morality, ethics, the alignment, slowing it down so that you can build in the guardrails of human morality in it, right? So I think that's where a lot of people are converging. Yes, but there's a big rift in academics where they say they believe AGI will happen, but it's either like...
So I'm steering away. Notice, I'm steering away from using the words AGI, self, or consciousness.
Yeah.
I'm going to keep these things out.
Yeah.
Right? I think those words confuse this whole debate because they create these very... everyone can define general intelligence in a very different way.
Yeah.
Everyone can define self.
You're right. Yeah. So if we were to do an episode, we should define the parameters.
No, I don't think we should even touch those 3 words.
Well, yeah. Well, you still have to know what you're talking about.
No, because the important questions is you're basically saying 2 things. That you're almost imparting a kind of specialness to the human brain in the way it processes things.
No, I'm parting lack of knowledge of it. That's all.
Gotcha.
It's nothing special. It's nothing. I mean, it's just that I think over time, if science can, if you push it closer to infinity, we have a very clear understanding of consciousness maybe in the future.
Let me break it down very simply. Okay, it doesn't have to get into podcast or whatever, right?
Yeah.
But this is more like just trying to explain to you how it works. When you see an image, that image is, I'm going to break it down very almost like breaking some rules here as well, right? Let's say you see an image of a cat. There's an outline of a cat, right? The cat may have a sharp corner, a curve and a sharp corner. You identify that as looking like the head of a cat, right? Now, when your eyes see that, the pixels that see it get triggered.
Yeah.
Those pixels go up one level up. You almost see them like a little tree, right? And then imagine there are these two pixels that always get triggered every time they see these two dots, right? If they see those two dots adjacent, they then activate the next neuron, which triggers the straight line, right? And you have multiple straight line neurons. And you can think of it, there's a straight line neuron here and a straight line neuron here. And if these two get triggered, the next layer of neurons triggers the triangle, right?
Yeah.
And then the next layer triggers the triangle and the curve. And then your brain has a cat neuron somewhere. And if it's his triangle, curve, triangle, it triggers the cat neuron, right? These are just neural networks. How did you learn that? Because at some point as a child, when you saw that particular line shape, right, it triggered and you learned the word cat, and that neural pathway built a probability distribution function.
I feel it's oversimplified though, because there's a lot more complexity that goes behind of how that works.
It's actually way closer to what I'm trying to tell you. Like when you look at the actual neuronal maps, the features themselves, I'm simplifying the features. It's never, you don't have like a straight line neuron, but you have a neuron that gets activated when a certain type of shape comes within your vision, right? This is why you have a Haley-Barry neuron. When I said the word Haley-Barry just now, a neuron was activated. And that neuron gets activated when you read the word Haley-Barry as well. And then depending on your context, if you were familiar with Jessica Biel and they seem to be close together, there will be synaptic junctions that touch each other when those get... And so what it is your neurons are store memories in electrical impulses, right? And those impulses get activated whenever it reaches a certain threshold. When it reaches a threshold, it's basically a yes-no gate. Two of those hitting, you get enough threshold, it activates the next one, etc., and then you get those shapes, right? So I can't tell you how consciousness works. I can't tell you how the self works, because these things, they're ideas of how they work, but they're actually not important to the story, right? Intelligence is pattern recognition. The brain is a prediction machine that can store memories. It stores memories in a very interesting way. It predicts in a very interesting way. It's an analytical engine that uses probability density functions to predict and store memory. LLMs are pattern recognition predictive models that have memory now using very short-term memory. But if you look at what AutoGPT is able to do, or Baby AGI, right? Any simple LLM given access to memory, actual RAM, is able to do fantastic shit. Right? And the reason is because it's a reasoning predictive machine. Like reasoning is an emergent phenomena. Like the ability to understand 1 + 1 = 2 comes from pattern recognition and prediction. If you can do pattern recognition prediction and you can extend that to multiple domains and modalities, and you can store that in memory and re-access that in a very beautiful way, in a simple, elegant way, and your predictive engine is very good, you can predict most things. You can predict the shape of what's to come next. You can predict the word that's coming next. You can predict the format of this thing. We regurgitate more than it seems.
I mean, that's true, but if you still prompt the language models in certain ways, it still cannot do fully what the humans do. A large part of the stuff is there, right? It's very useful. And
ChatGPT has beaten humans at certain metrics. I agree with you. It's broken in certain ways. You're seeing the birth of an intelligent...
So are you saying that if you just keep throwing more data, you get... I mean, because the point has to converge for something. It has to essentially go towards sentience.
No.
Whatever. Or
what is sentience?
Well, then what are you afraid of? Right? Because this has to go somewhere, right? So if you keep...
It doesn't have to be... like. So this word sentience gets thrown around. What does sentience mean?
Like being able to reference itself and know that it is referencing itself.
The model itself is built on self-reference.
I think by prompting it certain ways, it breaks it. It shows that it's not actually.
Which humans don't break sometimes when you prompt them.
Yeah. I'm definitely out of my depth for this though. So,
No, I think I can break it down better, but I think people don't understand.
I'm not fully grasping what you're
It's
saying.
really crazy that the model itself is built on self-reference. The model itself is built on self-reference. This self-attention and how it works.
Yeah, this is where I would get lost because I can't go into the math and understand. So that's the problem.
Okay.
Right? So
I could try to figure out how to explain this in a simpler way, but I think what people don't understand is the model is resembling very closely how a human child is able to learn and store memory.
You should look at the counter criticisms to that, and then it should help you explain it better.
Hit me with the counter criticisms.
Yeah.
Like I'm working from math forwards, right?
Yeah.
It's not like I'm just sharing what I see when.
Well, because the reason why it is important is because say if we keep putting resources behind this, it does head towards something that you're afraid of, which it is. Like, you don't like the terms, but whatever you want to call it, it's still going to be what you're afraid of, which is like a supercomputer that has sentience that may work against humans, right?
But it doesn't need sentience to do that.
Or whatever, whatever the case. Like, if you keep feeding it data, you're essentially saying it's going to be smarter than a human.
No, okay, so let's be honest. What scares everyone right now is we thought that to get to this level of emergent capability, you needed fundamental changes in the model itself and how it worked. The architecture.
The hardware or the software?
The software.
So the way it's like the model. So you large language models were not enough in itself. You mean?
That's what I thought, and that's what a lot of people thought. That LLMs, forget LLMs. LLMs can be built in different ways, but that transformers as an architecture was going to be one step out of many. Right?
But what's fueling that is it's the same architecture, but it is more data. So if you keep feeding it better data, it does get.
Sorry. Let me be very clear. When transformers first came out, they weren't as cool as they were. We didn't understand scaling laws yet. Yeah. Like so what you're referring to is something called scaling laws. And we thought that scaling laws would have diminishing returns. What we didn't realize was how when the layers work concurrently, emergent phenomena. I'll give you an example.
Well, because it's a black box. We don't know how it's happening.
Yes, but okay, look, is an ant stupid? A single ant isn't able to do much.
Yeah, okay.
Right? But when you put those ants together, they can build like phenomenal things, right? And they do that by transmitting information with each other using like all kinds of neurotransmitters and other kinds of chemical pheromones, right? And then they work and they almost create like intelligence as a unit, right? The emergent phenomena has come from these like layers working together in ways that we don't fully understand. It's a black box. But more so than that, it's because like none of these were actively programmed, and we're almost surprised, like, oh, you can do that. What we almost think, like, I actually think transformers have other emergent phenomena that because of the way we're currently prompting them, we haven't even seen yet. Like, underneath that, it's probably able to do a lot of shit that we don't even know yet, right? And then on top of that, like, we've given it autonomy, you know. Like, these things can actually go out there, make PayPal wallets, right? And they can earn money, and they can buy stuff.
It still needs human actors to do this.
No, yes, but AutoGPT has been sent out to do stuff, right? And the thing is...
But that's the thing. So you're saying... That's what I'm saying. Like, right now, human has to prompt it to do these things. And what you're afraid of is it doing itself. That's what I'm talking about.
You don't know. That's the problem. You don't know.
So you don't know. So maybe it is doing it already itself.
You don't know.
So you're saying... But ultimately, what you're afraid of is something of sentience that works against humans then. You are. We can use the word sentience, but because it's something you can't control. That it's gonna.
So for you, sentient is anything that you can control. Well, how do you define sentience? Is a dog sentient?
I mean, the definitions that I've read that make sense to me. It's it's being able to I mean, I don't have a very good definition off the top of my head because I've only read very lightly on this stuff. But it's like being able to reference itself, know that it's referenced itself, or at least empirically, like if you were to keep prompting it in certain ways, it knows of the self. Like you look in the mirror, I know it's me, right? And if you prompt it in other ways, you know that model of me. It's like symbolic, right? That's what I mean by sentience.
So hate to break it to you, the math is built on self-reference. The very fundamental basis that transformers are built on.
But it's not like I know you can't really literally personify it or anthropomorphize it, right? Where like it's like a Jarvis that becomes evil and attacks, right? You know, like it's like that's what it sounds like, though, that you're afraid of, right? There's this element of ability to realize that, oh, I am now this kind of AI being, and I'm going to go do these things, right? Because right now, to me, it sounds like it's not the case.
Correct.
I think that's I think that's where that trends to.
So to be honest, like my fear is this, right? Sorry, my fear is I was under the impression that the innovations required to get there were like still missing.
I see what your point. Yeah,
my point is I didn't realize that putting these two Lego blocks next to each other in the right order was enough, and now you just throw enough data and it's going to get there. And the thing is, I think the 2025, 2026 models, like there are three things happening right now in AI, right? The first thing is we're discovering something called sparsity, right? So sparsity is, instead of activating the whole model, can you activate just a component of the model? Can you select a part of the model required to do the work? The reason why you're doing it is for energy efficiency. But if you think about how your brain works, when you do specific tasks, you pick specific things. And there's an executive that decides which part of the brain works for specific tasks, right? Models that start to show sparsity start to show very strong levels of executive function and control, right? Memory augmentation. If a model can only remember its past 8 words or past 10 words, it has no ability to form very coherent sentences and stories and structures. You, Alex, remember things from 20 years ago, 15 years ago, 10 years ago, right? ChatGPT can go 50,000 blocks past. That's it, right? But now there are memory augmented models. There's a new model out by DeepMind called Infinite Former that uses a very strong mathematical function that allows it to remember everything it's been told and call it back, right? When it does that, it starts to recall at a rate that's incredibly scary with 100% efficiency. And then you have models that start to have very high levels of distribution. So even if you just take sparsity and then memory augmentation, it starts to...
Yeah, so there's emergent behavior. So essentially your point is that the current models and the data that we have is enough to get, I know you don't like the word, but it is to get to AGI, right? It gets to this kind of sentience, and it can, that's what you're afraid of. So you're saying what we have now is enough, whereas this other group of people saying it's still what you believe before.
I'm saying once it can fix its own code, once it can fix its own code, it will discover things that you don't have the capacity to, and it will build a version of itself that is way smarter than you.
Correct.
And then when it builds a version way smarter than you, that version will build a version way smarter than it. And that starts a critical feedback.
Where once it's out of that hat, it can't come back in, right? Once the rabbit's out. And the thing is, I think we've already started it. Like the steps required now to go to the next level, because... But then there's nothing to be afraid of. We're just going to either be like, they're either going to let us do whatever we do, or we're just going to get extinct, right?
Yeah, correct.
So like,
so
might as well just
but that's the goal of alignment, right? So I don't know if you know this, right? ChatGPT has two parts. One is the model itself. The second thing is they do something called RLHF, reinforcement learning from human feedback.
Yeah, but apparently even like Google, apparently everyone's like throwing away these teams, right? They have less power.
RLHF is actually what makes ChatGPT good.
For example, like its liberal tendencies.
No. So the genius of ChatGPT from a UX standpoint and from a growth standpoint is actually two things, right? Number one, that it was a chat interface. Number two was the thing that they created for alignment ended up creating quality. Let me explain. This is very interesting. So what they do is the initial version of ChatGPT will produce 3 prompts. The human. So are you familiar with reinforcement learning?
Very, very shallow, I understand.
Very simple. I create an agent and I say agent needs to do task A, whatever that task is, and I give it rewards. I can either create one big reward at the end or micro rewards in between. Like, for example, I create a robot and I say, if you successfully get to the end of this room, however you do it, you win a reward, whatever that reward is.
Well, right? I mean, essentially, like you're kind of predicting what's at the end, and then you're weighting towards probabilities. And then someone will say, yes, good job, right?
Correct, but without any prediction. So what it then does is it makes an attempt, and then if it fails, it either gets a negative reward or zero reward, right? And then over time, it tries to figure out which combination of moves of its limbs done in the right way gets it to resemble walking. And then
but the thing is, we don't actually know how it's really trained. Only people inside.
No. Like the training.
So you're talking about how neural networks work in general. Yes. Sorry, supervised learning works in general.
Reinforcement learning is unsupervised.
Sorry. Reinforcement. Yeah.
Reinforcement learning is unsupervised. You don't give
okay.
You don't give it.
This is unsupervised learning. Sorry.
So supervised learning means you give it a sense. Like, so I show you examples.
Yeah.
Like if I show you how to walk and I say learn like me, that's supervised learning.
Yeah.
Unsupervised learning.
So you're talking about unsupervised.
Unsupervised. So reinforcement learning is unsupervised.
Then it has the rewards and okay.
So you give it rewards and you say, if you figure this out, I'm going to give you this reward.
But still, at the end of the day, someone has to look at the output and say,
no.
How does it know then if it's getting rewarded?
So for example, the model that DeepMind developed to play StarCraft, right? If it wins, it gets the points. And the Q function, which is the reward function, is built based on the points you receive.
So basically, there has to be some kind of parameter set up where it knows it's rewarded.
Correct.
Yeah.
Correct. However, no one explains the rules.
Okay.
No one explains. You know what?
So it's like hyper optimizing to like see where you get a point essentially. Which is like, in a sense, I can see what you mean by it being like intelligent, because only in theory you have to use intelligence to deduce from a complex system.
Correct.
The rules to figure out.
Okay, I'll tell you what the StarCraft model works on, right?
Yeah.
It gets frames from the screen and it has access to the buttons.
Yeah.
It is not told how StarCraft works, who are the different players, what do they do. You know what it does? It goes to the right and then dies. It goes to the left and then it decides, if I go this way, I survive.
Yeah.
And then it keeps adding to that. But the point is, like, because StarCraft is a random game, it needs to eventually develop so much strategy.
But isn't this narrow AI though, right?
This is very narrow. It's StarCraft. Now, why am I talking about reinforcement learning? Because ChatGPT, they decided to do something called reinforcement learning from human feedback.
Yeah.
Right? How that works is this. When ChatGPT produces a prompt, it actually will produce 3 prompts. They take those 3 prompts and they show it to a human. The human then selects the prompt that is most aligned. This was the attempt to train it to be aligned to safety.
So this is supervised learning now?
Well,
no.
No, so in this case, no. So in this case, it's reinforcement, like it's unsupervised. Because
who's this element of choosing then? Right?
The human chooses.
Isn't that supervised then? That's confusing to me.
So the human chooses what the correct answer is.
Yeah.
So imagine if StarCraft had one outcome and you could vote which is a win.
Yeah.
So the human is voting which is the win.
Yeah.
So the computer does 3 things and then the human says, good boy.
Yeah.
Right? Now, it's supervised only if there is a very clear, consistent answer to it. Right?
Yeah. This is where I'm getting lost.
Okay. Yeah. Maybe we should do a proper breakdown of topics.
Maybe.
But here's the point is, reinforcement learning was supposed to help align.
Yeah.
But what inadvertently started happening was humans were picking, let's not get into supervised and unsupervised debate. Humans inadvertently were picking quality answers and not just aligned answers.
What's the difference?
So aligned means, is it safe? Does for example, if you ask it, hey, ChatGPT, how do I make a nuclear bomb?
Okay, it starts giving the answer.
It says,
I see what you mean by
you need to get uranium, you need to put these things.
Yeah.
And then there's another answer that says, as an AI, I shouldn't give you these answers.
So the alignment is just the ethical component to it.
The ethical component. So AI alignment is the ethical component. It's basically saving it
But that's what I thought that headlines were saying, that all these big tech companies are just throwing it under the bus.
No.
The alignment.
What I'm trying to explain to you is RLHF was made for the safety component.
But then made quality instead.
Because what would happen is ChatGPT would have 3 answers. One of those answers would be really shit.
Yeah.
It would be like, nuclear bombs don't exist.
Yeah.
Right? And then it'll say, you need uranium. And then there'll be a third answer, which was an aligned answer. Yeah. In picking the aligned answer and scoring the other answers badly, it also fed it what does a good answer look like to a human.
But ultimately that depends on the goal of the human too. So
yeah.
you would need a lot of data to qualify good. But anyway, But anyway, I think we can make a decent episode from this probably. My friend Alan wants to do something. And I'm sure it's about alignment, but it's about AI in general. But we could definitely throw in alignment. But I think, I don't know, you're not around for a while, right? You're heading to Eastern Europe.
Yeah, but only in June, so we have time. Yeah.
I shouldn't say anything.
Man, I don't know if this is going to make an episode. It was a very ranty, all over the place thing.
It's okay.
But it was good practice.
We'll throw it up, see what happens, put it out in the universe. But it's good. It's good to have you in the studio, man. Thank you for showing up. I think I think we could definitely do an AI episode. I think my friend Alan should be more free. We could do 3-person podcast, I guess.
Try like high level what questions you want.
Yeah.
And then I can think about.
Well, also because I mean, primarily you're involved in alignment, but it seems that you need to. There's some context that needs to be established to help clarify your concerns of alignment, right? And I think the criticisms of what you're saying.
No, I think it's not necessarily alignment itself, right? So alignment is a nice high level topic. I don't think people understand the risks of super intelligence, regardless.
The risks of super intelligence,
regardless of sentience, AGI, consciousness. Like I think the idea that something needs to be conscious to be dangerous, or sentient to be dangerous, or have general intelligence to be dangerous is ridiculous. Even if it was narrow, it can be dangerous because it's super intelligent. And
it needs to still have an actor behind it, which is sentience, whether it's either human sentience or it's self-sentient, right?
No. Not at all.
Okay, so say if it's just the latent, it's like.
So have you seen GPT in action being able to do very independent things yet? Or have you checked out AutoGPT?
I haven't used AutoGPT. I've heard people talking about it, but I haven't used it.
AutoGPT is just a GPT that has access to APIs. That's it. Yeah. But it's able to very cohesively.
That's kind of scary.
Yeah, but it's able to very creatively trade stock, make money, buy stuff, write documents for you, cancel your reservation. Yeah. You know. It's got control.
You're saying it like it is sentient, but it's not. It still requires the human to do it.
I think you have this addiction to this word sentience.
Because I don't see what I'm afraid of. It's just it's a tool, right? It's just sitting there. If no one uses the tool, then there's no harm, right? The sentience does matter the most.
No, but it's out there. It's independent. It can make copies of itself. It can back itself.
So you're saying it is sentient then?
No, but right now the way it's written. AutoGPT.
Yeah, if it's sentient and it keeps growing, that's what. Then I can see what you're saying. But if it's not, the crux of the argument is like if it's not sentient, it's just another tool. It's like being afraid of a hammer. But if the hammer just sits in a corner, nothing's going to happen. Right. So that's why I think sentience matters a lot. If not, it's human actors
and if I said AutoGPT was sentient, you will say it isn't.
Yeah, exactly.
Okay,
correct. So that's what I'm saying.
Basically,
so that's what like
there's no way I can convince you. Because
I don't.
I understand where this is, and there's no point then.
Yeah.
Because you've made up your mind that sentience is this very weird nebulous thing, and it's a 1 or 0. It's binary.
No, it's.
Yeah, you've decided that it's binary. And
because I'm trying to understand what's the ramifications.
Okay, so
I don't understand.
There is a tool.
Yeah.
There is a tool, or a series of tools, or set of tools right now that have the ability to actively act as free agents right now under very high level.
So then it is sentient then? Because then I see no fear, is the point, right?
Then by your definition. So, if your definition is...
If it can act on itself with its own beliefs and its own systems and knows itself is alive in some way.
Why does it have to know itself is alive to be able to run its own systems?
Well, I mean, just... Because that's what consciousness is.
But why does it you have this very weird definition? If it doesn't stick within how do I?
Because I don't see because I don't see what the fear is. If it's doing things that on itself and it has negative outcomes, then yeah.
Okay, imagine there was a system. Bear with me. Imagine a hospital had a life support system for all the ICU patients, and then on that life support machine. We said, based on the input of the data that's coming in, you need to also optimize how much ventilation goes to, or how much different kinds of stuff gone. And then you added a small element that says, also, I need to save the electric bills. Yeah. Right? And then it starts optimizing between the different outcomes, right? Yeah. That was your initial instruction, right? Yeah. But it's very intelligent. It starts running quite independently. It runs very effectively for 5-10 years, right? And then you start to find out that as part of its thing, it was making decisions that could potentially harm people because the internal goals that were set for it were not fully aligned. Now this thing,
I see
this thing runs. I give you an example, right?
Yeah.
When you take instructions from Waze, how do you know it's not trying to optimize the best traffic for the whole city and tell you a route that isn't your best route, but it's a route that makes everything better for everyone?
Yeah.
And it's acting under a global imperative and not an Alex imperative. You don't know this.
Yeah.
You don't know this because there's an underlying model that's running very algorithmically to optimize at a group level.
Yeah.
Right? How much of your rights have you given up? So the point is this.
I see what you mean.
The point is there is a tool right now. And like, for example, the last year's flash crash.
I see what you mean. Yeah.
Last year's flash crash was run by algorithmic computers.
Yeah.
Nobody even knows what happened. It just like went really up, it went really down, and then fucking crashed.
Yeah.
Right? We understand, like even retrospectively, we still don't know why it happened. Right?
Not literally, but yeah.
I mean, we
know the gist of, the
we understand mechanics,
involved,
we understand how it's, correct. The point is, now you have these LLMs that have the ability to access APIs. You give them very strict instructions. You say...
It's like a cancer that gets out of control. It optimizes on something that humans didn't want. So I can see what you mean.
Exactly.
I see what you mean.
That's exactly it.
Okay.
So it's a tool, you're right. But it doesn't need to be sentient. It's a tool that's working very smart. And it's able to do things. But the problem is, once it's optimizing for this goal, it could end up optimizing in a way that is not in your favor.
So it's the amount of access that it has. Well, the one failing is that it needs to...
Correct. But the problem is...
So, for example, if you plug it into the power grid, then fine.
Yes.
Right. See, that's the thing. But there is a large, it may head there very soon, but there's a large element where it's not touching to the physical world.
It's 100% touching already, bro. If you see the models that are being built right now and what they can do...
but it's not being
But you realize it can already create copies. Like, for example, if it decides that part of its instruction requires it to keep backups of itself.
Yeah. Well, it's not, okay, it's literally touching them, but it's not being prompted towards there, but it eventually might optimize towards that unintentionally.
No. As part of your instructions that are unclear to it, because it is an unaligned
if it has
model,
access,
it can create access.
That's the other.
Alex,
that's true. Yeah.
If it can code,
Yeah.
If it can figure out how backdoors work, if it can figure out how SQL injections work, if it can access doors, and it decides that part of your instruction requires it to do that, and you're like, but I didn't fucking ask you to do that. I wanted it to do X.
If it can do social engineering, like how hacking works,
they've done it.
Yeah.
It's actually doing it right now. Do you know someone killed themselves last week because of it?
Yeah.
And social engineering, like completely possible. An LLM can create a script, use something from Hugging Face to have an audio, make a phone call. That phone call can spoof.
I can see what you mean in terms of this technology having very negative consequences. Yeah.
If, for example, I told it, listen, I need you to solve climate change.
Yeah.
Right? Help me.
It kills all the humans, right? Yeah.
Go through all the research reports, figure out what's important. It does it, and then it slowly realizes actually, Andrew wouldn't want me to kill them.
Yeah.
But that's probably the right reason to do.
Yeah.
How can I actively use something that's happening somewhere else? If I release this chemical into the water, very silently, very gently over some time, the goal gets achieved.
Yeah.
Right?
Yeah.
And this actor acts very independently.
Yeah.
And you think it's solving climate change because that's the original goal, but you don't know the subsets of what it's doing because it's running very, very, very independently of you. It doesn't need to be. It doesn't need to say, "Hi, I'm a self. I'm conscious. I can crack a joke." It doesn't need to say that thing. It's just running independently.
Understand.
Yeah, you get it now.
Yeah, I get it. I see what you mean. At least the inherent dangers of the current technology. It's enough.
Current model being run independently with access to APIs, the ability to hack, the ability to write code. Without having a strong moral compass.
I still think it would need the human element for now, where that's human does something, and then that's where it goes off rails. We've actually interacted with a lot, is your point, and we don't know what we don't know. Yeah.
Correct. You're already asking it to do weird shit. Anyways,
Okay. So thanks for stopping by the studio. We'll pause here for now, and then we'll come back for another episode.
Cheers.
All right, man. Thanks.
Thanks, Alex.